We're going to talk about logging. So, this is the worst time slot. I actually think that this is a really exciting talk. I have been working in this area for several months now and have done quite a bit of work in this at Kroger. My name is Steve Shary, GitHub. I have a blog called stevesmashcode.com. At work, when I don't like code, I just typically delete it and rewrite it, so I felt like it was a good thing to do. And then I'm on LinkedIn, like everybody else. What I want to cover today in this talk is I want to talk about a failed example of traditional logging. When we talk about traditional logging, it's the idea of pushing it to a file on your local file system. So there's lots of libraries out there that do that, log4j, slf4j, .NET ones, Node's got some different ones like that. I want to talk about why this is a total disaster and you should never do it. I'm going to talk about current solutions on the market that actually will help you solve this problem, because if you don't use something, it will fail eventually. And then I want to talk about what we do at Kroger Digital. Kroger Digital is the kind of sub-department in Kroger that deals with all of the customer-facing ways with web and also with the mobile clients. We get to work semi-autonomously from Kroger as a whole, which is really good, because if any of you guys have worked at large corporations, you understand why that might be good. If you are interested in a job, contact me so I can get a referral bonus. And I'll contact my managers, who are 4 rows up. It's a nice way to do that. So who here has ever been on production support? Raise your hand. Yeah. It's horrible. And things go bump in the night, right? Sometimes they happen during the day, but you're really lucky if you're on production, if you're on a support call and you're in the rotation. It happens during the day, but it's usually at night. And a typical person will get a text. And it's from your boss. He says, you look at production, it's bad. And your boss doesn't really know necessarily what to communicate to you exactly, except for the urgency at which you should look at this, which they're not quite sure, so everything is very urgent. Please go look at it immediately. You check your email, because email will have a better message. That's kind of incoherent. Somebody is going on about how something is not quite working, and you're like, okay. And it's late at night, so maybe it is coherent, but you can't coherently read it. And they're very unhappy. They're very, very unhappy. If it's from a customer or a client, it's really unhappy. How could you do this to me? It's like a betrayal. So what do you do? Well, I'm a developer, and my code doesn't break. You were just using it incorrectly. So option number 1 is you're crazy. My code works fine. So I'm like, let's check it. Let's go see if it works fine. Let's pull up the web page. Oh no, this is bad. This is really bad. I think my website's important too. Oh no. Just as a caveat, at Kroger, we have nothing to do with healthcare.gov. This is just an example. Option number 2, maybe there is an actual problem with the code that I'm doing, right? Okay, this is like panic time, right? This is like when your heart starts beating really hard and you're like, okay, there's a problem with the site. I got to do something. It's down. You might actually go back and just hit Control-Shift-R, Command-Shift-R 3 or 4 times. Maybe it was a caching thing on my browser. It can't be down. We didn't do anything. We haven't changed anything in 3 months. Everything's been running the same way. Why is there a problem now? And you're like, I know. I just thought of it. Let's look at the log files, right? Because I'm a genius developer. And all of us genius developers have decided to put all the important information about our site into a log file. If we just look at the log file, It'll be like a simple treasure map that will tell us where the problem is. And we probably just need to reboot a server, so that's cool. So step 1, get the files. I don't have access to the box. That's not good. This is a production box, and for some reason, there are these laws that got passed like 10, 15 years ago, and now I'm not legally allowed to get near production for some reason. I can't even remember why. But the business won't let me actually see the production box, even though it's my code that's out there. So please fill out a form and request access for your logs. This form is usually in some sort of antiquated system that you have a hard time getting to, or you hate it so much that you forget it as fast as you can. And oh yes, you hit the submit button and you say, oh, there's a 1-hour SLA to handle all severity 1 requests from the infrastructure team. Please hold on while we get your log files for you. And then they say, okay, here's a temporary password for you to get onto the box, to get the file. Awesome. I'm going to get the file right now. Oh, crap. It's 3.5 gigs. And that's not good. And I'm on a VPN because I'm at home, right? And for whatever reason, however great we are with technology, it seems like we are always cursed with having the worst internet connections at home. And so it's going to take me like a long time to like pull this file down. And now everybody's paging me and everybody's sending texts and they're looking at me to solve it. And now like your blood pressure's really going up. And you're thinking this is really bad. And should I be feeling a pain in my chest right now? Am I feeling shooting pain? Oh, no, I'm not. And you're like, okay, I can do this. I don't need to pull the files down. I will just go look at the files on the box. If you can't bring the problem to yourself, go to the problem. Let's look at the log file. It's still 3.5 gigs. It didn't magically change size. Oh, there's 5 other files too. Holy crap. Now I have to search through a lot of data, like 17.5 gigs of data. And this is going to be really bad. And okay. And the server that you don't have access to, and you didn't get to put your whole developer environment on that box. You didn't get to put anything on that box. And the infrastructure, deployment, production team, they don't like putting stuff on their boxes because it's more stuff for them to deal with. So you need to use one of the most common editors on the server boxes, right? And if you're in Windows, what's it going to be? Notepad. Let's notepad that bad boy. Holy cow. There's that's a failed attempt in itself. If you're in Linux world, you get VI, right? Now, there are the exceptional few people who are VI ninja masters and can open these files up, and with the totally obscure commands of VI, can actually go through and look at the file. And that's totally cool. And let's say that I actually can open this file on this box that took me 15 minutes to get to, and I have the maintenance page there the whole time. Well, I got another idea. Let's not look at the file. Let's tail the log files. Let's watch it as it comes out. I haven't done a lot of Windows production support, so I don't know, is tail a thing on Windows? I'm sorry to ask this as a dummy thing. It's a big Linux thing, and basically what you can do is you can say tail-f, and you can say just show me what's being pushed into that log file as it's happening. And you can just watch the stream of data go into your log file. And there's 2 possible things that are going to happen with your log file. The first one, water everywhere. And this is what happens when you tail your log file. You're like, oh my gosh, right? It reminds me of like the thing in the Matrix where Cyrus is talking, and he's like, yeah, the program constructs can't they can't decipher the matrix. I just look at the code directly, like there's a blonde, there's a brunette, that's a person over here, right? No mere mortal can actually look at this and make any sense. And then when you get down to it, there's a problem. Because you realize that there's cleanup from the last time that this happened. Because when you look through your log file, you see all these warning and error messages, but they're like, got into the function, started going into the function, did this thing in the function, reached this if statement, this is the value, got out of the function. And that's repeated like 300 billion times. And you realize that you put a ton of logging into your application the last time you had a big major error, and you got it fixed, and everyone was happy, and the stress rolled off, and you went out to the bar, and you promptly forgot about it all, and now 80% of your log files are filled with the problem that you had 2 months ago. And now you have no hope of finding this problem. But wait, there's another option, because let's say that you're good at that, and you clean it up. You might have this issue. That's it. And you tail it, and you think, is the application running? You're like, oh, no, it is. It's telling that this number is interpreted as a hex value. Any idiot could know that. Why did we even put this log message in here? Why is this the only thing that's in here? This is the worst idea ever. We have to go delete that immediately. And there's this thought that runs through your head. Maybe I should just take this log line out since I'm going to be deploying the application pretty soon anyways, and that way I can kind of clean this up, which is not good because you need to get your application running again. So here you are, and you're going through, and it took you like 20 minutes to realize that you can get onto a box, to get to a file that's too big for you to open, that when you tail it, it's spewing out so much crap that you can't decipher what's good, or it's not spewing out anything at all. Well, let's assume that you were able to get past all that. Let's say that you found your message. Like this little bottle floats off the ocean and lands on the beach, and you're like, an error message that looks like it correlates to what I saw in the application. I did it. I did it. I'm there. 90% of solving a bug is just figuring out what the problem is. I'm the man. I'm going to solve this, ask for a raise. Everything's going to be great. Wrong. One error message is not enough for a diagnosis. This is when people get into what I call voodoo programming, where you're like, I saw this error message, so if we just do this, it should go away. So let's put this in. So you do that. And then you deploy it. And the same thing keeps happening. And you're like, oh, well, my error message went away. And you go repeat the whole process again. Because now you got to find the new error message that actually gets to it. And these are the other problems associated with this. Usually, a person doesn't do one interaction with your system. There's like 10 or 15, like they got to your site, they pulled down index.html, they pulled down your JavaScript and CSS files, they logged in, they went to the other page that showed your stuff and their account status, then they clicked on like pay the bill, and then after that, then there was an error. And there's like 40, 50, 60, sometimes hundreds of calls that take place for all this. And you found one error message for one call. And here's the thing that's even worse. Your application isn't just one box. There's a whole bunch of other applications that it talks to. And your application might not have really been the problem. It might be someone else's problem. And this is where you have this little spring of hope. Maybe it's not my fault. Maybe I can just pass the ticket on, right? Maybe it's a database issue, right? I don't know why we're running low on connections. I don't know why the resources are running low over there. Maybe it's their fault. They should have responded in less than 5 seconds for my request to get something. And if you get back up just a little bit, you typically don't run one instance in production. If you want to run high availability, you run 3. If you have to scale up to demand that's like bigger than nothing, you're typically going to have 4, 5, 6, 10. If you're like super cool and you're running a gigantic site, you'll run like 50, 100 different applications that all do the same thing. So now you got to go to every box and look for it. Should we despair? I mean, I know people have been in this spot before. I have. You know, it's not cool. I worked for a sunglass retailer, and I took down the point of sale system for every retail place in the United States for like 4.5 hours, stopping all sales. I think that was bad. They said millions of dollars of sales lost or something like that. So time is of the essence, right? You need the right tool for the problem. I like to do it-yourself home repair, and I have learned that if you don't have the right tool, you will just kill yourself trying to do it. I had a friend that wanted to fix some stuff on the foundation of his house, so he just decided with a plain shovel to dig out around his house to help seal in an issue, and he almost killed himself. He's crazy. So we need the right tool. But let's define what this tool is. What should this tool do? So if we looked at our use case of what went wrong, the first things that we should do is we should centralize all of our diagnostics. Everything should come into one place. If you want to be cool and get onto the cloud and do elastic compute and spin up boxes and kill them and shut them down, you got to push your data into a centralized place, because you can't be trying to go out to each and every box out there and try and figure out what they're doing. Separate your logging system from the application. There are 2 reasons to do this. Reason number 1 is that the majority of the time when you want to see the diagnostics of your application is when it's no longer working properly, and if your diagnostics are tied to part of your application stops running, you will stop getting your diagnostics. That's not good, because then you're like, I just need to get the site up so I can look at the log files. And that's a bad place to be in. And vice versa, what if your logging system decided to stop working properly and in turn decided to take down your production application? Well, then your boss is going to tell you to remove it. And then you're going to be back to log files, and that sucks. Real time, or close. We worked on, I'm going to talk a little bit later about a system we used, and it actually had a 2-minute lag from real time, and it drove us bonkers. When you try and reboot a system and you want to see if it's coming back up online, and you just need to sit there and wait for 120 seconds to make sure it's working properly, I can tell you that a lot of people want to sit there with their twitchy hands and just keep doing other stuff to make sure it comes up and running. So you want a system that will tell you very quickly what the status is and how things are running. Visualizations. There's 2 reasons for wanting visualizations. Number 1, it's hard to see trends in numbers when you're just looking at the raw data. And so visualizations will allow you to know, like, oh, look, we're peaking out and plateauing. Oh, look, we're climbing up exponentially. Oh, look, we're going down. Oh, look, it's flat. Oh, look, it's all over the place, like the jagged teeth of death. And we should do something. Also, visualizations encourage people who are not as technically deep as you to also get in and look at the systems. And some people might think, like, I don't know if I want my boss to know exactly how production's going because I'll just take care of it. But I've actually found it's really good to have your management in and understanding what's going on, because they're going to get a more realistic expectation as to how things work. And it's easier to kind of ground non-technical people to reality if they already are seeing the outputs of what's happening in reality. Next, a drill down capability. Obviously, it's super great to see the Earth from 50,000 feet, but it's a lot nicer to actually live down close on Earth. And when you have a production issue, it's great to see that there is a box that's on fire, but it'd be really nice to know what specifically is causing it to blow up. And so you want the ability to drill down and look specifically. Also, if you get really, really good at this, you can start hooking up your support call center to your diagnostics so that when a user has a specific issue trying to log in or get an action done, you can actually provide the call center with the ability to get what happened to that user. And so you've probably done this if you've talked to a non-technical user that describes a computer issue that they have, and what they describe is actually very different from reality. There are a number of things that my father has done where he's called me on the phone telling me about his router and how it's all completely broken. And I was finally smart enough to be able to remote into his machine and then actually look at what's wrong, and it has nothing to do with that. So actually getting the facts for a specific person or a specific session is really great to have. And then lastly, alerting. Alerting is really nice. Nobody likes to get paged, but it's really nice to know before like the world's on fire that there is an issue, because alerting can let you know that things are about to go bad ahead of time, and it doesn't require everybody to sit there with eyeballs on, you know, your diagnostic solution. So these are the things that I think are really important and things that we use at Kroger Digital. So if you haven't messed around in this area, if you haven't really moved on from logging files, that's okay. I want to talk about a couple common terms, so you know when you go and talk to a commercial vendor, they don't flash you with all these terms and you're like, wow, you're super smart, because I never even heard of that thing. The first one is APM, Application Performance Management. This is kind of like a weird niche offset of logging in which companies will go and install like libraries, agents, or basically separate processes that sit on your production boxes, and they will give you back generic performance data about how your application is running and how people are interacting with it. This is not you writing log files. This is about them putting their thing in, and it just starts streaming data out and tells you about how your system is running. And we're going to talk about some of the solutions in here. Synthetic monitoring. Synthetic monitoring is the idea that you can send controlled input into your production system, and a system will verify that it got the desired response back in a reasonable amount of time. We do this by having synthetic monitor users log in, you know, do a small thing, make sure that the page came up, and that we were able to see kind of the key performance indicators and the key parts of Kroger.com were actually rendering and working correctly. So there are synthetic monitoring things out there. There is this idea of like, if a tree falls in the forest and nobody hears it, did it really fall down? Did it make a sound? And in the same way, you could say like, well, if my site wasn't running and nobody came to visit it, was it really down? You can kind of think about that a little bit, you know, when you have spare time, but we do see some value in this. EUM or RUM, this is end user monitoring or real user monitoring. This is the idea that it's great to know what's happening on your servers, but if that's all that you look at, then you forgot about your mobile app and the actual browser. Because you think, well, I just serve out HTML and a JSON API, a REST API, and everything just works great. And it's like, yeah, but if Chrome crashes all the time, that's not a good product to give to the customers. So EUM and RUM are the idea of embedding small pieces of code in the mobile applications or putting a small JSON library into your actual client code to send metrics back about how long things took. And it is somewhat interesting because you get a lot of really crazy data like where people are, what type of connection they have. You realize that a lot more mobile people probably use your site than you would expect. And that, oh, responsive is a lot more important than people might have thought. The last one that I wanted to talk about is correlation ID. If you have a browser making a call to your server, and your server makes a call to an internal service, and your internal service makes a call to a database, and the database responds, and it bounces all the way back, you want a way to watch that call shoot through your entire server space, your entire production system. And correlation IDs are the idea that you can generate a random number and just start passing it through. And then when you have all these logging entries that have the same correlation ID and it's in a database, you can just search for that correlation ID and get all the information that happened for one request. And it's really great for understanding like what are the slowdowns in your system, like why did this take very long? And then you get this really freaky thing where you're like, okay, my application gave it to you, and it said it took 1,000 milliseconds. And the other application's like, well, it only took me 20 milliseconds to give it back to you. And then you're like, what happened to that other 980 milliseconds? Where did that go? And you start finding like really interesting gaps in performance, and there are things that you might need to address that you didn't realize were even an issue to begin with. Let me get some water. So let's talk about some solutions. Let's talk about commercial solutions first. Let's talk about the APM solutions. These are the application performance monitoring solutions. The first one up is New Relic. I felt like I should put them first because they are a sponsor at this conference. They're really good. I actually have not used them, but I've had several colleagues that have used them at other companies. There's Appdynamics, really good. I've used this one at Kroger. And there's a third one out there called Dynatrace. Also a good one, I guess. I don't actually know very much about Dynatrace. But all of these guys are APM solutions. And the APM solutions are ones where you're going to install like a library, a separate process. You might embed something in your application, but it's a very, very like small thing that you do. And these guys will start shipping data out to a centralized place. So one of the pros of using an APM solution is it's really fast to integrate. You know, I know that with Appdynamics, it uses for Java, it uses a Java agent, and so you basically just add that into your command line parameter, and then poof, everything just starts working magically. And I know that with New Relic and Appdynamics that if you want to, you can make changes to what data is being fed back to you without doing reboots on the system. So it's basically you can make hot configuration changes as to what data you want to pull in. So you can leave your systems running all the time. They have nice user interfaces. It's a commercial solution. They make it really nice and flashy so they can get you with the marketing stuff. It's great. It works with crappy logging. This is a really nice feature because there's a lot of crappy logging out there. And it's a standardized data collection. So everything that comes out of an APM is going to be a standardized data format because they're the ones that wrote all the collectors to pull all your data in. So let's look at the cons. The cost. It costs money. And money is a hard thing to get your boss to spend. And it doesn't fit in the budget. And they're not sure like what value you'll get for it. And this is my beef with these guys, is that cost is per instance. So a lot of these will say you have to pay this amount of money for this number of server processes that are running. And this is where like I feel like this is license-driven architecture, where you will be pressured by management to make architectural decisions based off the licensing models of the things that you use. So your manager says, I really want to add this new feature in, and you're like, great, I'm going to spin up a new microservice using fancy microarchitecture, and I'm going to have a new separate service, and they're like, yeah, but we're going to have to spend another $800 for another collector license. Can't you just group it in? And then like 6 months later, you have this gigantic monolith that's saving you like $800, and it's horrible, and you're like, screw it, I'll just go back to log files. There is this idea, if we ain't got it, you don't need it. So they tell you exactly what data you're going to get back, and it comes back nice and customized. But sometimes you're like, it says the box is red, and I don't know why the box is red. And all it says is that there's some sort of error. There's like a null pointer, but I don't know where it is. And I don't know how many there are. I really want to put some logging in, but this isn't logging. This is application performance management. And so the idea is, if they don't give it to you, there's not a lot of room sometimes to pull extra data out of the system. We also see that it gets kind of wonky with async. A lot of these APM solutions will use like fancy techniques to correlate a call that goes through the system. And if you're using an asynchronous model for making calls that go out, it gets kind of confused. And I've seen a case where we did an async call, and amazingly, this one login call that came in made like 6,000 requests out over the span of like 2 days. I don't know what happened there, but it seems to get a little wonky as you move to asynchronous solutions, and that's been kind of like an important thing to do in terms of scalability. Let's look at logging, because there are logging. Oh, sorry, I forgot about this one. Most do sampling. So there are ways for the application performance management systems to give you specific details about individual transactions. The problem with this is that they'll take like they'll start and they'll say, we're going to sample 3 every minute, and you get a very in-depth look at one single transaction, which hopefully represents the whole. And we found that it's very difficult sometimes because you get the wrong sample, or the sample is incomplete, or the sample doesn't give us the data that we want. And we really wish we just had all the data for every transaction. And I will say this is one differentiator, because Dynatrace, when you crank that bad boy all the way up, will give you the details for every single transaction, every single request that happens out there. Logging. Let's look at some commercial solutions for logging. The big elephant in the room, the one that's always kind of been there since about 2007, is Splunk. Splunk is really nice. Splunk is very easy to use. Just throw your log files in. It works great. You can have it on site, or you can do software as a service. Super great. Sumo Logic. They're a newer one to the field. They want to try and show themselves off as doing both logging and APM at the same time, so you kind of get a mix of both. This is a pretty good solution. It is a software as a service solution. I don't believe that they have anything on-premise. Loggly. This is another new one that's come in. This one is also software as a service solution. I don't believe that they have anything on-prem. There are a whole bunch of these, both in the APM and in this spectrum, that are commercial. I can't go over all of them. If you're a vendor for one of them and I didn't go over it, I'm really sorry. It's difficult sometimes to ask the internet. I'll go to the Google and say, Google, which ones are trending up and talked about a lot? But these are the ones, the top 3, both for both of those, that I thought would be best. Again, these have nice user interfaces, splashy graphics, very cool stuff. You can make your data analysis as fine-grained as you want. Put 1,000 debug lines into your application. Ship them all into there. You can get all of the data that you want out of it. It's super awesome. The downside is that you have to put all your log entries in there and push it in and get them shipped out. If you don't put the logging in, it won't tell you. So you have to be proactive up front to get all the data out that you want. These cost money, and that stinks. And here's the rub on these. This model encourages you not to log, because most of these solutions will say you have to pay X amount of dollars per day per gigabyte of data that you log into our system. So you're paying, like, I was looking at the cost model for Splunk, and they were saying like their first one started like $10 a day or something like that, and that was if you only pushed 1 gig of log data into their system per day. So 1 gig per day, that's all you get. If you start pushing more data in, the meter starts ticking up. And what this ends up doing is this goes back to encouraging people not to log data, which I felt like was the whole point of using these things. So kind of hard. Haphazard data formats. You're pushing the data in. If you were the only person writing the application, sure, you can make all that data consistent and the same, but you're going to have lots of people, and everybody eventually puts a log entry in that says, got here, did the thing, no exception, or even better in your try-catch block, got an exception, not sure what to do, ignoring. So let's look at the open source solutions. Elk is the first one. This is Elasticsearch, Logstash, and Kibana. I would imagine that a lot of these software as a service solutions probably use Elasticsearch. This is kind of considered the dominant data store for just totally random, whatever formatted data you want to push in. Elasticsearch basically was built as a search engine, and you shove JSON data in, and then it lets you search over like words and partial words and whole things. And then they realized that it's really useful for logging because people just put all sorts of random garbage in there and they can still find it and pull it back out. Logstash and Kibana. Logstash is the mechanism to get data into Elasticsearch, and Kibana is the nice visualization that you can show with it. It's pretty cool. It's the one that I'll talk about the most as we go into what we did at Kroger. But there are gaps with this solution. This is not a complete solution. Graylog 2. It is not Graylog 1. I guess Graylog 1 didn't go so well, so they kind of said, we're not going to do Graylog 1 anymore. We're going to call it Graylog 2. And a lot of people have actually said that Graylog 2 is a lot better than Graylog 1. And Graylog uses Elasticsearch as its database for all of its searching stuff. And it's a pretty complete solution. It's kind of enterprisey, so you get you can do LDAP and Active Directory authentication and authorization as to which data can do what, and it's pretty cool. FluentD. FluentD is like this nice delivery mechanism in which it says you can just deliver lots of data from your syslogs and all sorts of stuff, and we'll put it into any number of things like Hadoop and Elasticsearch and MongoDB and whatever other NoSQL database you can come up with, and probably a SQL database as well. FluentD, I would say, out of all of these, is the least complete in terms of solving the problem of doing performance, and logging analytics. The pros is the cost. It's open source. It doesn't cost anything, right? It's free. You can make your data analysis as fine-grained as you want. This is just a nice thing about these. These will pull log data in. These are not APM solutions. You can use it as much as you want. You can use it a lot, and we use ours quite a bit. And then there's this feel-good idea that you can be like, one day I'm going to make a change to this and contribute and give back to the rest of the world, and I'm not going to be a leech on the open source community. I'm going to give back. But you can at least feel good about that, right? The downsides is that a lot of these solutions are not totally complete. I will caveat and say that Graylog is pretty complete. But it does lack the ability to do a lot of the extensions that at least we've wanted to do at Kroger, so that was a downside for that. But the other ones are very open for extension. The downside is the cost. If these things are incomplete and you want to use this, that means that you will have to complete them. You will go to your solution and say, you complete me, or I complete you. And that will take time, and time is money. And you still have this problem of haphazard data formats, and that's not cool because everybody formats in different ways. And then you have to do the integration with the logging. So that's kind of an overview of the systems that we have. So out on the market today. Let's talk at what we did at Kroger. So we started with Appdynamics. This was at least back in 2013. Since then, I know we've been using it. My colleague Jeff and I started tinkering around with it a lot. We started instrumenting a lot out of our system, and then we realized we were the only people that were doing it at the moment. It was really great. We got really addicted really fast. Then we said, let's build a dashboard. Let's build an awesome dashboard. And we decided since we're developers and we're awesome at making visualizations, let's make our own. So this was our first visualization. It's our little baby. So you can see we had two parts. We had our pharmacy part and our main site. And it just showed us how many accounts we had, how many homepage hits, refills. And this was actually really popular. We had VPs looking at this, and they'd be like, oh my gosh, look at today, it's so high. And we're like, it's 11:30 at night, it's really high, and it's going to reset in the morning. And it was just really great. And then there were other times where you'd see the error percentage go into the yellow, and you'd be like, oh, this is really scary. What are we going to do? We decided we wanted more information. We iterated on it. We built another dashboard, or set of dashboards, in which we got even more data. And this was even more useful, in which we started getting data on specific calls that were happening. And we could kind of see the response times, error rates. We had these nice trend graphs that were just beautiful. I mean, they went up and down, and we're like, wow, homepage hits. Occasionally on homepage hits, we get this middle finger, Like in the middle of the night, for some reason, we had like 800,000, homepage hits. And we'd be like, what was that about? And then every so often, the security team would be like, oh, we ran this test. Sorry, we didn't tell you. So at Kroger, we kind of did that for a little while, and we just wanted more. We needed fine-grained transactions. We started seeing that we knew that there were errors out there that we wanted to get more specific details on, and Brent Tipperman and Jeremy Gerke, who are awesome guys, decided that they wanted to just start streaming log data into a centralized place and not just sit on an APM solution. So out of that, we started with the ELK solution, which is the Elasticsearch Logstash Kibana solution. And we quickly removed Logstash. We added in filtering because we realized that people might accidentally put like sensitive data into their log files. And we're like, that's not good. So Jeff, who's really awesome, wrote this application called Linux that like on the fly would go and remove sensitive data that we did not want to have move into the system, and we redact it. And we added Kafka. Who here has heard of Kafka, the open source project? Okay, so Kafka is a open source like topic, and it's awesome because it's massively horizontally scalable. They talk about being able to do 1 million writes per second into the clusters. I know that it's being used at Google, LinkedIn, like mega sites. And we decided to put Kafka in as the first landing place because occasionally we will get completely inundated and slammed with log data as the system might get a mad rush where for some reason somebody goes out on Twitter and says that Kroger's giving away $100 coupons if you just go to this one page, and then all of a sudden like 800,000 people show up to this one page, and we're like, lots of data. And then we moved to a 3-tiered visualization solution. That's where we're kind of at right now. We had the really high-level ones, the dashboards. We had the mid-level ones, which is Kibana, that's kind of baked into the ELK thing. And then we have a lower-level one called Mazer, which allows us to go down into individual transactions, individual calls. And out of this, we created this cool system we called Echo. And yeah, the Kroger guys are going to clap because they're like, yeah, we made Echo. It's a really cool project that we've been working on, and we really are excited to be able to open source this soon. So we'll be open sourcing the different pieces that we put together with the ELK stack that we think made it into a production-worthy solution. Let's see here. How am I doing on time? Am I doing good? 15 minutes, excellent. So this is kind of a little diagram. So a lot of our clients will send something into our GORP application, which is our reverse proxy that we wrote in Go, called GORP. And basically what that allowed us to do is to just switch to just do a distribution to Linux. Linux is our in-flight guy who does filtering. And then we also do rate limiting in Linux because occasionally applications will start writing invalid data into the system at ridiculous rates. And it was nice for us to just kind of turn the spigot off for some of those inputs. And that was really great. Kafka is our landing pad in which we can do like a bazillion writes at the same time. And essentially what happens is that data gets shoved into Kafka, and then on the other side we have this Kafka Elasticsearch consumer. We call it KFC. I forget why. It should be KEC, but we all call it KFC. I started calling it the kernel, and then that didn't stick, so it's just KFC. And KFC will pull data out of Kafka as fast as it can and put it into Elasticsearch. Elasticsearch is our gigantic database. We put a lot of data in there every day, and if you just kept putting data into a database, it would eventually fill up. And so we have this little application that runs on the side called Winnow, who sits there and curates our data. And Winnow deletes old data and moves it along and reshuffles everything about. And that's something that we have going in progress. And then we have our visualization tools. These say Kibana, Beacon, and Mazer. Beacon is our alerting tool that reads off of Elasticsearch and sends out text. And we have an internal paging system that it sends out things to. Kibana is our visualization that comes with Elasticsearch and the ELK stack. And then Mazer is our drill down. The high-level dashboard one that we had working with Appdynamics, we call it Atola, and I'm in the process of moving that over to work with Echo data, so that'll be really cool. So talked about a lot of stuff. What does it look like? This is a screenshot of Kibana. This is what Kibana looks like. I pulled this off of the Elastic site. Our dashboards look just as cool, but it is just a lot of eye candy. It is a lot of really, really cool stuff, and it's really great to be able to show people what we're doing. And that's kind of where we're at right now. So what do we do now? We collect about 500 gigs of data per day across just Kroger Digital. I don't know if we've ever actually done an estimation if we open this up to all of the Kroger technology stuff that we do, but I would imagine we'd probably be in the terabytes of data per day that we would collect. We collect data from Apache web servers, Nginx, Java web applications, Node.js applications. We have a .NET client, which I feel like is in beta and should be used somewhere. Is it being used anywhere right now, Jeff? Kind of, not really. There's a guy that's like, yeah, I'm going to use it. I really want to use it. I just hasn't done it yet. We hold data for about 25 days. That means, if you can do the math in your head, that we have about 12.5 terabytes of data in our database right now. And if we were to pull that up, that's how much we have. It's a lot of data. We're working on Winnow, which helps with the curation because our database actually can hold 45 terabytes of data. And we are in the process of rolling up our performance data because we realize that after about a week, nobody cares about the individual transaction that happened 7 days ago. It's usually only within like the last 2 or 3 days that you're doing really, really fine-grained analysis. And so we are moving to where we'll be able to have 90 plus days across all of our stuff. And that's awesome. What can we do? We can see a problem about 20 minutes before it happens. Occasionally, an alert will go out, and everyone's like, oh, that's not good. And I'm not on rotation right now, so I'm just going to kind of ignore that. And then 20 minutes later, a bunch of emails start shooting out, and you're like, oh. So we do see it, but we don't prevent every problem that happens. But we do prevent a number of them. And sometimes it's just a matter of a server instance just started going bonkers, and we just kill it and reboot it, and it comes back up. Everything's great. No customer impact, and it's awesome. We can trace down problems to specific users. Sometimes not all of our users are friendly users. We sometimes have malicious users. And there have been cases where we find out that a user is not really a user, it's just a bot that wants to scrape data off of our site. And we've successfully been able to go in and using Echo identify who those are and then actually just go and lock their account and shut them off. And then they create another account. And then we are like, oh, it's from the same IP block. Let's just block all that. And that's been really awesome. We start freaking out when we see 2% error rates. If you think about it, if there's 100 people in the room, there's probably a couple hundred. That means that like 4 of you are not able to log in. That's a problem because 4 of you will probably write something on a social media site somewhere about how much you hate Kroger. And we are going to solve that. And this is good because before that, a lot of people don't really see what percentage of errors that they have until they hit like the 50% threshold or the 75% threshold. Or they hit the executive threshold where the CEO tries to do something and then an error happens and then that email just kind of shoots down. You know, like Zeus throwing a lightning bolt from heaven. Someone's going to die. We also see blips, like garbage collection. It's really interesting to be like, wow, why did that request all of a sudden just shoot up? And then we start seeing that certain things. We see garbage collection pauses in managed code systems. And what that really allows us to do by being able to get down into this deeper is that we can go deeper into the code and deeper into the problems. We can identify things that we couldn't do before without log files. It's awesome. Like, we're not perfect, but like we're able to really set the bar really high when it comes to the service and capabilities that we provide. And it gives us the opportunity to learn from our mistakes and the problems that we have. Where do we still struggle? Because we've been doing this for several years now on these moving off of log files. Consistent logging, it's still a problem. I wish that somebody would write some really nice documentation about proper ways to do logging, but it's kind of a subjective thing, and then it'll turn into like this huge religious war, and then we'll not really get anywhere. We can still also just ask people to just write things into a log file, like just write a log entry, like write it somewhere so we can pick it up, because some applications will log almost nothing. All you'll see is just that little drip of errors, and that's very difficult. And then once you've even gotten everybody to put great log data in, we still struggle with empowering teams to use their data. We get 500 gigs of data in a day. That doesn't mean that we look at all 500 gigs every day, or we even aggregate and roll that up. We are still working to empower teams to use that data and act on it. The last interesting problem is, what time is it? Like in distributed systems, time is a really difficult thing to pinpoint down, because we'll look and we'll say, okay, this system at millisecond 452 went over to talk to this one. But this guy said that he returned his response at millisecond 178. But that's impossible, because that was before he sent the request. And then these systems are kind of all over the place. And then you're like, oh, this is really difficult. And so time is actually a really difficult problem to figure out when you're in distributed systems. And you want your stuff to go fast. You don't want any of your calls to take 3,000 milliseconds. You want them to take 50 milliseconds. And that's where you see clock drift with NTP. And that's even if you're using like real hardware with real clocks and things like that. So that's Kroger. That's where we're at. So the question might be, as we start getting towards the end, where do you start? Put your logs someplace that's not on your box. Try and push them to a centralized system. Linux has syslogs. I know that Windows has a similar thing as well, and that you can push those logging files out of your production box into someplace else. Start by getting all your log files into one place, even if it's just a matter of just shipping them across. Okay, get them moving off the box. Do a simple aggregation, right? In the Linux world, you can do grep-c. You can count how many times you see something, and you can do that all the time and just say, how many times am I seeing this happen? Everybody likes to be the cool person that can write little scripts that count things. So be that cool person that can count how many times you get errors every minute or every 2 minutes. Okay, do that. Make a small visualization. Speedometers are really great. They tell you a lot. You know, bar graphs are really cool. Everybody wants to do the 3D line graphs and all that kind of stuff where things jump across the page, but just start with something. You know, get that out there. That will really whet your company's appetite for doing more of this. And then lastly, I would say try commercial vendor. Especially, you know, Splunk's a good one to start with. Appdynamics, New Relic. These guys are great ones to start out with, because you can put this on a single application. You might have that one horrible application that no one likes to support. It always causes you problems. There's always just random stuff that happens. Get a commercial vendor in and get them to give you a trial to use it. And you'll be able to see the value of this, because there is a lot of value in moving away from log files. So we have a little bit of time for questions. Does anybody have any questions for me? I ask a lot of questions. Yeah?
What do you feel about storing log messages in your relational database?
So the question is, what do I feel about storing log messages in a relational database? I think that's totally fine. Relational databases require you to declare your schema ahead of time. And so the thing about log files is a lot of people want to do expressive logs that can have a different schema. So yeah, it's totally possible to do. You know, if you feel more comfortable with that, just try and get something out there as fast as you can. That's going to be productive. On the blue shirt. So the question is, we're at 25 days, we want to go to 90 days. What is that really going to give us? There aren't any use cases I'll expect everybody to do, but I periodically will get a technical lead, a manager, or a developer that will come up and say, hey, we saw this happen like a month ago. I can't find that data anymore. I want to pull that up to compare that. And that's where that 90 days is useful. I do expect that we'll probably call the data off a bit sooner than that and just keep our rolled up performance visualization or rolled up performance data, because watching performances over like the long term is a really nice thing to look at. Yeah, in the gray shirt?
So you said that your system altogether is what you call echo, right? So, and that's what you said you're looking to open source. Do you have a timeline for that?
So the question is, do we have a timeline for open sourcing? Where's my manager at? We're waiting on legal. So, yeah, so we have a couple things. We have some companies that we work with that Kroger has purchased over the past several years. And we actually deploy all of our stuff in Docker containers. And we actually have a Docker compose file. So you can just say Docker up, echo up. And you can bring the entire echo ecosystem. You can bring that up. So yeah, like we can kind of bring that up as a whole. I don't think that we'll be open sourcing everything all at once. We'll probably be doing like different pieces. So what we'll recommend to people is say, start with the elk stack, add this piece on. This is really going to allow you to get going. And what's out there on the elk stack today is getting pretty complete. And Elastic, which is the company that makes Elastic, the whole elk stack, is actively working on adding new features in. They just recently added alerting and things like that. So people are moving on the elk stack to really finish it out. Any other questions? Yes? Yeah, so that's why we pulled. So the question was, he uses ELK. They use HIPAA-sensitive data, so it's healthcare related, and nervous about pushing any HIPAA-related data into the system, because when you push HIPAA data into a non-HIPAA place, it's really bad. And lawyers get involved, and we're already dealing with lawyers for the open source stuff. So that's why we put our initial Linux guy in that does the filtering, because there are specific things that we look for. And I know that Nick, who's one of the technical leads for our pharmacy team, has a lot of care and diligence about what data he puts into Echo, and I see him actively scrubbing the data before they push it out. So we really we're somewhat autonomous from Kroger Technology as a whole, and our management has empowered us as teams to be somewhat autonomous from each other. And so we take responsibility for what we do. And so if a team feels like they're responsible enough to push data in that could be sensitive, we expect them to be able to scrub that data so that nothing that they shouldn't put out there actually does get put out there. In the rare case that there might be a mistake, Linux, which is the entry system that does the filtering, we can also just turn it off immediately without rebooting anything. And so we have that ability to stop it. Any other questions? Okay. Thank you, everybody. I hope this was useful for you guys. And if you want a job, come talk to me. So this is my information. Check out my blog if you want to. I've been talking a lot about automated testing and rants about that. So thanks, everybody, and enjoy the movie.